So the video solutions for the summer exam from 2014 for dynamical systems and chaos. So question number 1, you have to sketch a phase portrait for a linear system. One part B, we want to find a Poincare map for this planar system. So for question 1A, if we write the linear system in matrix form, here is the matrix. We can put this into MATLAB, and using the eig command, we can do vect_val equals eig of this matrix, and these are the eigenvalues. And notice we don't put down the eigenvectors because they are complex. So this, because the real part of the eigenvalue is positive, this is an unstable focus. To work out where the flow is vertical and horizontal, we look at the isoclines. So x dot is 0 when y equals 4x, and x dot is 0 means the flow is vertical on this line. And y dot is 0 on the line y equals minus x over 4, and on this line the flow is horizontal. If we look at the line y equals 4x here, then you can see when x is positive, so we're looking at this branch here, we have vertical flow. So if you look at y dot, if you put y equals x 4x, then y dot is 17x on this branch here, which means that when x is positive, y dot is positive, so the flow goes up. So now we know that the flow is going anti-clockwise. So we know that this goes to the left, this one goes down, and this arrow points to the right, and then the flow is always counterclockwise. And then you can see I've plotted two trajectories here which spiral away from the origin. For part B, we have dr by dt is minus square root of r, d theta by dt is 1, and we're given the initial conditions, r at 0 is 1 and theta at 0 is 0. So now we've got to integrate. So if we integrate dr by dt is minus root r, we can separate out the variables, so we get a separable differential equation. We can simply integrate this, and we end up with the square root of r is 1 minus t over 2, because the constant c1 is minus 2. And if we integrate 1 d theta equals 1 dt, then we get theta is t plus c2, and of course because theta is 0 is 0, c2 is 0, so theta is equal to t. Now because we're dealing with Poincare maps, t is going to be the same as theta, which is 2n pi, multiples of 2 pi. So that means that Rn, if we square both sides, Rn will equal 1 minus n pi all squared, because we square both sides. And now we want to find Rn plus 1 in terms of Rn. So we put Rn plus 1, we replace n with n plus 1 to get this term, and simple algebra can show you that this expression is the same as this expression, and now we can substitute for 1 minus n pi squared, because that's Rn, and that gives us our Poincare map. And that concludes the solution for question number 1.